So friends, in this video we are going to learn how to read the schematic diagrams, and I have here compile motherboards, and this model number is LA Z801P. So this is a compile motherboards, and this diagram is a total 102 pages. This page is basically the block diagram. Okay, and here is a mention the processor name. The processor here is the iselect, so that means the 10 generations. Iselect processor 10 generation, and here is a descriptions are given. So here is the ADP ports for the display. EDP stand for enhanced display ports, and DDR4 RAM supported, and here is a ESPI bus. In previous model they use a LPC bus, but after 10 generations they have started using the ESPI bus for the SIO. And here is my SIO. SIO's number is a KB9052 on the page number 58. Okay, and here's my BIOS, SPI BIOS, that is on page number 9. SPI ROM 128 MB. Keyboard and touchpad is connected to the SIO. Here's the HD ports for the sound, USB ports, and here is the IO ports, PCI Express connected to the hard disk or Wi-Fi or SD, SSD. Okay, and this total is a 102 pages, and power of this diagram, any diagram, the normally the power most of the last few pages. So if you scroll down, then so here is a power requirement to the laptops, and we'll see, zoom it and we'll see. So this is the power. So these are the different chips. So this is RT3612, generate the VCC in power, then the VCC in aux power generated by RT6543, and here's a 1.2 RT8207. 0.6 is going to the RAM. 5 volt generated by SY8288C, 3 volt generated by SY8286. Okay, so in this way, these are the different voltage, and here is a CPU core voltage is a 1.05 voltage. So these are the different voltages are given to the different chips. Okay, so here is the inputs, adapter and the battery. This 3 VLP is going to the SIO. It's called the LDO, low drop output. And now we'll scroll down and we'll go the power, the first page, the battery charging section. So we'll scroll like this. So okay, now this is called the ladders. Okay, so this is very important when you are going to repair any laptop. If is such type of ladders there, then simply you have to follow this ladder. This is the power state when you plug in, and then the different voltages are generated. Just I'll explain you this. So this is 19 voltage. When we connect the adapter, then the second thing is 3 VLP voltage will be generated. That is 3 VLP voltage generated by the 3 volt chips, that is called the LDO voltage, and this voltage is going to the SIO. SIO get this voltage, and then SIO generate this EC on signal. Okay, and if the SI is not given this EC on signal, that means the SI is bad. Then you have to check EC reset, then you have to check lead switch, then you have to check thermal trip. If the all signals are there but still EC on signal is not generated by the SIO, then the SIO is bad. After EC on signal, SI is going to turn on this 5 volt, okay, that buck converter output, and here the system will wait to press the power button. Okay, so here is my on off switch. So once I press the on off switch, then the 3 volt enable signal will be generated by the SIO, then 3 volt always voltage will generate, and then SPOK signal will be generated, then 1.8 voltage will be enabled, 1.8 volt power good, then VCC aux, then VCC aux power good, that is 1.8, then VCC in, that is a CPU core voltage, CPU core VCC ST power good, then 1.05. So this all voltages are generated one after another, and then the this here is a down, this EC RSM RST will be generated, AC present will be generated, PM power out generated by the SIO to the PCH, and then the PCH will give SLP S4 and SLP S3 signal, and then the SIO started turning on the CSON SUS. When you generate the CSON, then 1.2 and 2.5, this is voltage for the RAM. 1.2 for the VDD and 2.5 is a reference voltage to the RAM. Then SUSP signal, that is a 5 volt suspend, 3 volt suspend, 1.8, this voltage is going to the PCH, and the 0.6 the VTT voltage will be generated. Okay, and then the VCCST power grid, that means the all powers are okay except the CPU core. This signal is given to the CPU, and then the SIO is going to turn on this VR on signal. VR on signal turn on CPU core voltage, that is called a VCC in, and then when the all powers are generated, then the PCH will going to turn on these two signals called PCH power okay and system power okay. The PCH power okay, that means the all power okay, and system power okay also means the all power okay including the CPU core voltage, and this both signals are the 3 volt and given to the PCH, that means the CPU. Okay, because in this diagram the CPU and the PCH is a combined, and after receive this two signal, CPU is going to generate one signal that is called the platform reset, is called the PLT underscore RST signal. So this is a very important signal, PLT reset. So once the PLT reset will generate, then the CPU start reading the BIOS. After BIOS will act after the PLT reset only. Okay, so remember that. Okay, so you have to follow these steps. You have to start from top and go to one after one signal. So if I want where from which chip generate the signal, simply what I have to do is just click a right click, select this arrow, select this signal, copy this signal, come to the edit, click on the find, then paste that signal name, that is 3VLP, and click next, next, next. See, so here is my SIO. Okay, so this 3VLP is going to the SIO pin number 111, 96, 33 and 22. Okay, so this 3 volt is going to the SIO. Now if I want to know where this voltage is coming from, then I have to click next, next, next. Yeah, see, this is my uh, 3 volt and 5 volt chips. So this is, see, this is the, in any diagram at the bottom of the corner there is a mention the index of the page. That means what the information is there on this page, that is real, that is mentioned in the bottom of this corner. So what you have to do is you have to go this down and you have to read this information, that is plus 3 volt always and plus 5 volt always. That means this section is a 3 volt section and 5 volt section. So this chip is basically for the 3 volt, and this chip is basically for the 5 volt. So it's like that. So this chip generate a 3 volt. So once you receive this 19 volt and you generate the 3 volt like that. So you have to go like that. So you are, what you have to do, you are that ladder which I shown you, just select that signal and check the signal one after another. If signal is coming, then you have to go the next, 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 like that. And if one of the signal is not coming, if missing, then you have to check why that signal, particular signal is not coming. You have to find the source from where that particular signal is coming from. Okay, so now what we'll do, we'll go back, and what we have to do is we have to come here and we have to check your how much voltage. We have to check 3 volt. Now if the 3 volt is not coming, then we have to go back and we have to check this input, because this chip is a single chip buck converter. That means in this chips the buck converter is there within the chips, MOSFETs are there, and linear regulator is also there. Okay, so this chips generator, this chips receive a 19 volt, and these chips have a two enable 1 and enable 2. This LDO enable signal is generate, and it's here is require minimum of 3 volt, and once you receive a minimum of 3 volt, that enable signal, then after this chips generate this 3 volt, and this 3 volt is going to the SR. Now if the SR is not getting this 3 volt, then you have to check this 2 signal, that is a input signal, that is a 19 volt here, and 3 volt, minimum 3 volt here. If one of the voltage is missing, then you have to go back and you have to check why that particular voltage is not coming. And if the both voltages are coming but still the output is not coming here a 3 volt, then this chip could be faulty. It's like that. Okay, and once this chips get this 3 volt, then now what we'll do, we'll go back and we'll see the battery charging section. So here is my battery charging section. So here is my input coming from the adapter. Then these are the two P channel MOSFET, and here is my battery charging chips, and location of the battery charging chips is a PUB1, and the chip number is a BQ2478. Okay, so this is the chip number, and this chips receive a power at pin number 28. So here is a pin number 28. So this 19 volt is coming from here from the adapter, and this voltage is going to the pin number 28. So once these chips get the power, then these chips will turn on, and these chips require one more signal, that is called the AC detect. This pin number 6 is called the AC detect, and here is some divider circuit. So this is a divider circuit. There are two resistors connected in a series, and 19 volt is given here, and this resistor is a PRB11, and value of this resistor is 422 kilo ohms. Okay, and 1% tolerance, and this resistor value is 66.5 kilo ohms, 1% tolerance. So here is somewhere around to 2.4 voltage will be generated, and this 2.4 volt is given to the pin number 6. So once this chips receive this voltage at pin number 6, then what he do is he drive this AC drive signal, and this AC drive signal is connected here and drive this two MOSFET. These two MOSFETs are there, and both MOSFETs are N channel MOSFET. The MOSFET location is a PQB3, and number is a EMB04N03, and this voltage will travel from here to here and then travel from here to here. So here you should supposed to get a 19 volt, and if the 19 volt is coming here to the gate of this MOSFET, but still the voltage is not transferred from here to here, that means from drain to source, then this MOSFET is bad, so you have to replace the MOSFET. So remember friends, first you should know the this thing, what symbol of the MOSFET. First you understand the symbol, whether this MOSFET is N channel. So if you want to understand the proper schematic diagram, then the two things very important. First thing, you should know the value of the component, their function, their purpose, and their symbol. The second thing is their symbol you should know, otherwise you not able to understand the diagram. Okay, you should know the purpose. So here is a MOSFET is an N channel, and what is the purpose of this MOSFET? MOSFET purpose is a switch. So how we'll know the MOSFET is N channel? The arrow is inside. So if you don't know the electronic, then you have to go back and understand the basic electronic concept and circuits and the symbols. Okay, so the voltage will travel from here to here, then voltage will travel to here, and here is my current sensing resistor. The value of the current sensing resistor is a PRB3, and the value of this resistor is 0.01 ohm. So its value is very negligible, which sense the current, and that current is sensed by this battery charging chips. And then once you receive the current, then from this two pin, this is the pin number 11 and pin number 2 is called the SM bus, and this SM bus information is going to the SIO, informing that the adapter voltage is present. And here is a one more signal, is called the ACOK, and this ACOK stand for adapter current OK, and here will be generated 3 volt, and this 3 volt is going to the SIO, informing the SIO that the adapter voltage is present. Okay, so in this way you are to understand the diagram. And here is the two MOSFET, switching MOSFET for the battery charging purpose. So these both MOSFET are N channel MOSFET. When the battery need the charge, then this two MOSFET started switching. Then this battery drive signals are there. The SM bus is communicate. Then this they're going to turn on, and here they got a 19 volt, and that 19 volt started switching. And here the this is the buck converter started functioning. Here is one more current sensing resistor measuring the current to going to the battery and coming from the battery, and this the battery started charging. When we remove the adapter at that time, this MOSFET works. So here is a MOSFET number is a PQB2, and this MOSFET is an N channel MOSFET. So voltage coming from here via this path and coming here, and when this battery drive underscore charge trigger to the gate, that means the 19 volt come here across, then this voltage will travel from the here to here, from source to drain, and then this is like a junction. Okay, so this is called the battery charging sections, and this section is called a 3 volt and 5 volt sections. So this is called the 3 volt and 5 volt section, which already I explained how that section is work. So this is a separate, this 3 volt is a separate and the 5 volt is a separate, so both are independent. Okay, now what we'll do, we'll go to the SIO and we'll check. We'll go back. SIO is an upper pages. So here are some pages are reserve pages. Okay, so here is my SIO. So what is the number of the SIO? SIO is the location is a U11. U11 is a location number, and SIO's number is KB9052. Okay, KB9052. And first thing, if any SIOs need a power, so SIO need the power is a 3 volt, and you can check this 3 volt any of this pin, either 22, 33, 96 or 111. So once you get the power, then the second the most important signal is called the EC reset. So you have to check the EC reset signal. EC reset probably on the left hand side only. So we'll check whether it's C. You can see here the mentioned EC reset. EC reset. This here is the EC underscore RST pin number 37. So here you have to check a 3 volt. So once you receive the 3 volt at EC reset, then the chips will start functioning and generate a EC on signal. EC on signal. EC on signal is here pin number 112, and this is going to turn on 3 volt and 5 volt sections. Okay, it's like that. And you have to check this lead switch also, pin number 115. This lead sensor is one kind of sensor which check the lead of the that is sensor. Here is supposed to come a 3 volt, and once we press this power button, so this is the input power button, and then this chip started functioning and generate the two signal. That most important signal is called RSM RST, the pin number 11, pin number 100, ECRSM RST. So this is the output signal coming from pin number 100 of the SIO going to the page number 11. So this is called the page number. So this is the output signal, and another signal, that is a PM power button. So this is the input power button that user press, and there is a one more power button. It's called the PM power button. We'll see where it is. It's not here. Yes, this one, pin number 112. PBT now. So this output signal is going to the CPU that the power button is pressed. So here you will get a 303 pulse. If this 303 pulse is not coming, then you have to check all the previous signal, and you have to check the EC bias also, because this SIO is a programmable SIO. So if this 303 variation is not coming, then first you have to flash the SIO with the new bias, and if still it's not work, then you have to replace SIO and reflash the bias again. Okay, so here you should get a 303 variation, and after that SIO received SLP S3 and SLP S4 signal from the CPU. So we'll see where are those signals. SLP S3, or SLPS4. So you can find the signal like this also, SLP. I'll type here SLP. Yeah, SLP0, SLP0. Okay, where did this page come from? Okay, so SLPS3 and SLPS4 signal not mentioned here. So sometimes it's written SUSB and SUSC. We'll see SUSB is there, SUSC or SUSB, SUS, SUSP, SUS signals is there. So SLPS3 and SLPS4, SLP underscore S4, SLPS underscore S4 is signal. Yeah, SLPC, you can see after pressing a power button, that PM power button just started bounce, then the SLPS3 and SLPS4 signal generate, and this signal generated by the CPU. So you have to check this signal. You can check the signal anywhere. Here are some test points. So this is a CPU generate this SLPS4, SLPS3 and SLPS0 signal after receive this RSMST and PM power button. So you can check this signal at you can't check the signal at the CPU, but of course you can check the signal at here. You can find this Q6 and you can check the signal here also, or you can check this signal here also, or you can check the signal. Uh, you can check the signal. Yeah, you can check only here only. Yes, you can check this Q6. Okay, this signal SLP SLP like that. So friend, in this way we have to follow the steps of the schematic diagram. So this is the first part of the power sequence. That means if the laptop is not going to turn on, and then simply you have to follow these steps. I hope you understand this concept.